Okay, so today we're doing partition labels. This is a medium problem generally asked on Amazon around 140 times in the last 6 months. So basically we have a string S of lowercase English letters given, and we want to partition the strings into as many parts as possible. So that's the maximum number of parts possible, so that each letter appears in at most one part. So if say the letter A appears in the first partition as many times as it wants, it can appear in the first partition. But if it appears in the first partition, then it can't appear in any consecutive partitions. And we need to return a list of integers representing the size of these parts. So we don't really need to store all the entire substring that we are dividing. We just need to return the length from the start. So like if 0 to 9 0 to index 9 is the first substring, so probably we can just return 9 and return a vector which has 9, and then if the second one is from 9 to 16, then 7, and then so on and so forth. So basically, first what we need to do over here is create a last occurrence vector or an array. If you don't know what vector is, it's just an array. It's the same thing. So what we need to do is we need to go through the entire string, and we need to find out what is the last occurrence of each and every string. So this helps us in a way that when we are trying to find what is the last occurrence, we don't need to actually go through the entire string for each and every letter that we encountered during our actual operation. We already know what it is. So this will take n time. N is the length of the string. So we will declare a vector of int, which will be last occurrence, and this will be, we can just define that it will have 26 values because there are 26 letters in the English alphabet. So go through, actually we'll also declare a len variable because we'll need to use len again and again, and the length operation is more expensive than just using a variable again and again. And over here what we can do is last occurrence of s of I minus a equals to I. So I will give the index and say a is occurring at the 0th index and then at the 10th index. So because we're going from 0 to till len minus 1, we will last occurrence of a will become 0, and then later when we are at the 10th occurrence at the 10th index, we will change the last occurrence of a to 10. And what this s of I minus a is doing is mm, converting the characters into like a corresponding to 0 and b corresponding to 2, because the ASCII of a minus the actual ASCII of a, and like the ASCII of b minus actual ASCII of a will give us 1 and 2 and so on. So this is done. Then we will declare some helper variables, which is, first of all we can use, okay, first we will have a vector of length. This will actually store our final answer, and we also need current division count. So this will store how many divisions have we made to the entire string till now, and the starting point for the current division, which will start from 0, and the ending point for the current division. So the ending point for the current division would be wherever the last occurrence of the current variable is. So over here you can see that the first letter is A. So we find what is the last occurrence of A from this entire operation that we did. So we find out that the last occurrence of A is over here. So that will be the ending point. Then we go through this entire substring which is between A, and we find out if there is any other letter which occurs after A. So in this case, I don't think, okay, so sorry, this is the last occurrence of A, and I don't think there is any other letter. Yeah, there isn't any other letter. But okay, so in the second substring, which starts from D, we find that the last occurrence of D is over here. So that would be the endpoint. But we also find that when we are going through the substring which is between D and D, we find letter E, which has its last occurrence after D. So that will become the endpoint. So we need to figure that out how to do that. So right now the endpoint will be last occurrence of the starting point. actually it will be s of starting point minus a, the same thing that we did before. Yeah, I think that's correct. So now we need to go through the entire string again. So what we will do first is we will find out if I is at the endpoint. So whenever I successfully reaches the endpoint, then that means that there are no characters in between the two boundary characters which have their endpoint greater than the endpoint. So when I is equal to endpoint, what we can do is we can increment current divisions. This is just to keep track of how many divisions we have. Actually, we don't really need this, so we'll just get rid of this. This is just when I was trying to figure out the logic, I was doing something with current divisions, but actually we don't need this because we can just push back the length over here. So what we can do is length dot pushback. So now what will be the length? The length will be the ending point minus starting point plus 1. So ending point minus starting point plus 1. And we also need to change the starting point now. So once we find out that the entire substring, the first division is still here, the starting point which was at A over here, we need to change that to D. So what we do is starting point will be I plus 1. Yeah, I plus 1. And we also need to change the ending point because the ending point currently after A gets over will be at A, and the starting point will become D. So we need to make the ending point the last occurrence of D, but we also need to make sure that that starting point is actually valid. So if say the starting point is over, like the last division occurred at J, and then the starting point became J, like whatever jth index plus 1, so that would not be a valid place to store, valid place to access in the string. So we need to also make sure that the starting point is actually valid. So we check if the starting point is not equal to len, then we can update the ending point with starting minus a. Yeah. So that is one part, and the next part is to find out if there are any letters in between our boundary characters. So if A and A are the boundary characters, we need to find if any of these letters have an ending point which is greater than the ending point of our boundary characters. So for that we do is last occurrence of s of I minus a is greater than our current ending point. So that's about it, and in the end we can just return length. In 16 what happened? Use of undeclared. Okay, I guess the spelling is wrong. Yeah.